processor or memory interconnection. Hello, in the previous lectures, we discussed the processor and memory separately. Here, we are trying to know the interconnection of CPU and memory. In the computer, the size of memory is determined by the addressing scheme. The address space of a computer represents a size, that is, number of addressable memory locations. For example, 16-bit address of computer generates 2 exponent 16 memory locations. 32-bit address of computer generates 2 exponent 32 memory locations. 64-bit address of computer generates 2 exponent 64 memory locations. In memory, we basically store and retrieve the data in word length quantities. If 32-bit address is being sent by processor to a memory unit, the high order 30 bits determine which word is to be transferred, and remaining low order 2 bits determine the byte location. Processor memory interconnection consists of address, data, and control lines. With address lines, processor specifies memory location and data lines are used to transfer the data. Simultaneously, read and write commands are carried by control lines. Word or byte to be transferred, and timing operation used by memory to indicate the operation is also determined by CPU. When memory operation is completed, processor's internal control signal, that is, memory function complete or MFC, is asserted. When this signal gets asset, processor proceeds with next instruction. For example, a memory organization of 1024 times 8 means 1024 memory locations with 8 bits per location. So how many address and data lines are required? Since we know that number of address locations is 2 exponent n, thus 1024 equals 2 exponent n, so n is equal to 10. Now, each location requires 8 bits, so memory requires total 8 bits to transfer the data. When read operation takes place, the 8 bits are placed on data lines. The whole memory size is 1024 times 8, that is 8192 bits. Intel 8085 microprocessor has 16 address lines which are unidirectional and can transfer 65,536 memory locations. It has 8 data lines which are bidirectional. Speed of memory units is measured by 1. Memory access time. It is the time spent to initiate the operation till its completion. Basically, it consists of latency and transfer time. Latency or response time is overall time taken to transfer the data. 2. Memory cycle time. It is the minimum time between start of 2 operations. It took longer time than memory access time depending on the implementation of hardware. It is measured generally in nanoseconds and should not blurred with processor clock cycle time. The access time of storage devices such as magnetic or optical disks depends on address or position of data, whereas RAM has access time which is independent of address or position of data. Nowadays, there is a trend of multiple processors. So multiple processors have the ability to share single memory units, virtual and cache memory. The speed at which the processor can access data is very large as compared to that of main memory. To compensate the speed difference between the main memory access time and processor, cache memory is employed in the computer system. It is used to store segments of a program currently being executed. It also stores the temporary data frequently needed during program execution. It helps to increase the computer performance by providing the program and data at a rapid rate, since now the CPU will not access data from main memory, instead will access from cache. The cache memory is typically integrated with CPU chip or placed on a separate chip with a separate bus to interconnect with the CPU. As the CPU processes data, it firstly checks it in cache memory. If it finds the instructions, CPU need not to do time-consuming reading of data from RAM or other storage devices and thereby speed up the program. Virtual memory is another way of memory organization in operating system. It is that space where we can store large programs into pages or active sections for execution in main memory. Rest are stored in secondary storage device. Consequently, large programs can be stored and less input-output are required. When data transfer takes place between main memory and cache or main memory and secondary storage device, data can get transferred in terms of block having large number of weights. These blocks are in contiguous form. That brings us to the end of the section. Thank you and see you in our next section.